electrochemical cell is made of two cells known as cathode and anode. Basically, you're separating the reactions, the oxidation reduction reaction, into two separate containers. So in one cell, reduction taking place, in another cell, oxidation taking place. The cell that oxidation is taking place is called anode, anode for oxidation, and cathode for reduction. Reduction takes place in cathode and oxidation takes place in anode. You have two container, or could be like beakers with the solutions. You have two electrodes. The nature of these electrodes, it depends on the reaction. So if your reaction is reduction of copper, so this is going to be copper. It could be graphite or it could be copper, but if it's copper, then copper that is reduced, it means that copper is changing from Cu2 plus to, it's gaining 2 electrons to change to Cu solid. Then that solid copper is going to deposit over this copper electrode, and this copper electrode is going to gain mass. On this side, we have the zinc solution. Zinc is being oxidized, so we can make this electrode out of zinc. So the nature of the electrodes, it depends on the type of reaction. You can also use like graphites, as long as the electrons can be transferred using those electrodes. But it's more clean if you have the electrodes available from based on the chemical reaction. If it does matches the chemical reaction, it's going to be easier and more clean process. We have a salt bridge. Also, what's the purpose of salt bridge? Is going to maintain the charges. As oxidation takes place in this side of the reaction, in this cell, when the oxidation is taking place, that means zinc is losing electron and is going to change to zinc 2 plus. So this zinc from the electrode is going to change to zinc 2 plus, and it comes to the solution. So the positive charge is going to go up in the solution because electrons are going to move up through the wire and going to anode, to the cathode, because it's needed there for the reduction. So electron is moving up, but the zinc 2 plus is going to go into the solution. So the plus charge is going to increase, concentration of plus charge is going to increase in the solution. As a result, from the salt bridge that we have, the salt bridge is made of, in this case, potassium chloride. It could be potassium nitrate, it could be sodium nitrate or sodium chloride. In this case is a potassium chloride. The chloride ion is going to move to the anode because in anode oxidation takes place and plus charge is being produced. So the negatively charged anion is going to move from salt bridge to the anode. What is happening in the cathode? Reduction is going to take place. So we get a Cu2 plus being consumed, changing to Cu. So the charges or positive charge is going to decrease in the solution, and because we want to maintain the positive charge, the K plus of potassium ion from the salt bridge is going to move to the cathode area to compensate for the loss of the plus charge, because the plus charge is changing to a neutral or a zero charge for copper. So the salt bridge is going to help us to maintain the charges into two half reaction or in the two cells. So anode oxidation, cathode reduction. Electron is moving from anode to cathode. What's happening in the salt bridge? We have a plus we have cation and anion. Anion is moving to the anode to make up the negative charge or to cancel the plus charge that is coming out. As a result of the oxidation is produced, and the cation is moving to the cathode. Cation from salt bridge is moving to cathode to help to maintain the positive charges. Otherwise, you would have like too many of the SO4 2- left over and doesn't know what to do. You don't want your solutions to be charged or handle extra charge. So for a spontaneous reaction, the electron is moving from the anode to the cathode. The oxidation is happening in the anode and the reduction is happening in cathode. We have two half reaction. Electrons are gained by Cu2 plus to change to the Cu solid. This is called reduction, which is happening in cathode. And then zinc is being oxidized. Zinc is losing electron to change to zinc 2 plus. And this oxidation reaction takes place in anode half cell. The difference in the electrical potential between the anode and cathode is called the cell voltage or cell potential. The diagram, you have two ways to show what's in cathode, what's in anode. One, to draw this whole thing. Label this cathode, label this anode, and show that copper is being reduced in cathode, zinc is being oxidized in anode, or write the diagram in this format. Okay. What is this format? You are separating the anode from cathode using two parallel lines. In this case, the left side is going to be anode, and the right side is going to be cathode. So you're separating the anodes from cathode using two parallel lines. And what's happening in the cathode for the previous experiment or for this reaction that we have here, copper is being reduced. So this reaction is taking place in cathode. So you would say copper 2 plus is changing to copper. This is happening in cathode. What's happening in anode? Oxidation takes place, and zinc is solid, is changing to zinc 2 plus, and this is the AQ. So you have your anode reaction separated from the cathode reaction using the two parallel line, and then the reactant from the product with just one single line. So based on this diagram, is another way of representing or presentation of the electrochemical cell. Reduction in cathode, oxidation in anode, and use that separation. For standard cell, concentration of the solution is going to be 1 molar. If it's not standard, then you might have different concentration for the solution. Standard electrode potential is compared to hydrogen, all the elements compared to the hydrogen. So for hydrogen, the potential is considered to be 0. Reduction of hydrogen, when H is going to gain 2 electrons to change to H2, the reduction in this reduction potential is considered to be 0, and everything else is going to be compared to reduction of hydrogen. So when we have the reduction of hydrogen as a reference, then zinc going to zinc 2 plus we can find out the cell potential or standard electropotential when zinc is going to zinc 2+. So everything is compared to hydrogen. So E0 equals to 0 volt when hydrogen is being reduced, and this is the standard. What condition? The concentration of the solution is going to be 1 molar, and then the pressure 1 atm. The cell potential is going to be E cathode minus E anode. So this E cell standard EMF for the every reduction is recorded in tables, and those numbers will be provided unless everything else is provided, and that is the question. So you will get these numbers basically in a table. So reduction of the zinc is going to be 0.76, and then reduction for copper 0.34. A different number is going to be different value. So in this case, reduction of the zinc is 0.76, or oxidation is going to be plus 0.76. Reduction is going to be minus 0.76. So if it's written at the way that it is based on the reduction half, then we have these values, and we can work with those values for calculation later. Okay. For copper, when it's compared to the to hydrogen, again, this value is 0.34. That's for reduction of copper. So we have the we are comparing that to hydrogen. In this case, hydrogen is being oxidized and copper has been reduced. So copper is compared to hydrogen as a reference, being 0 here. Then we find the reduction of the copper to be 0.34, to be measured as 0.34. So hydrogen is losing electron to copper to be reduced. This is the table that I was talking about. The higher positive value, that means that element wants to gain electron or wants to be reduced more strongly. So the highest number that we have here with the positive number, highest positive number is for fluorine, that is by gaining electron is changing to fluoride ion, and it has the higher E0 value. So when you're comparing two, the higher the value is, it's easier to be reduced. And then the lower it is going to be easier for it to be oxidized, or it's not easy to be reduced. The more positive E0, the greater tendency for the substance to be reduced. The half cell reactions are reversible. So when you reverse the reaction from oxidation to reduction, or from reduction to the oxidation, the sign for E0 is going to change, is going to be opposite. Standard potential for a cell that is made of cadmium and chromium in 1.0 molar chromium nitrate. So if this reaction is spontaneous, the total must be a plus value. So we write the reduction half for the 2. For cadmium to be reduced, the E0 is a minus 0.4. Chromium being reduced is going to be minus 0.74. In order for the final answer to be positive, now this value must be positive. If this value is being positive, that means that chromium is not being reduced, chromium is being oxidized. So in order to change this value, we have to change the concept. So this is for reduction. That means we have to change this one to positive. So chromium is being oxidized. So we rearrange that. Chromium is being oxidized. And when it is oxidized, it's going to release 3 electrons. And cadmium is being reduced. So this reaction takes place in cathode, and then we have the reaction for anode. So cadmium is going to be reduced by gaining electrons. And then for the cell potential, when you add the 2, because this is now oxidation, you have to change the sign from minus is going to be plus. So plus 0.74 minus 0.4 overall is going to be 0.34 volts. Volts is the unit for the electricity or the cell potential, the difference. Okay, I think I'm going to stop the recording one more time.